Goal: determine how far each card travels per frame, attempting to be as precise as possible. The ruler is irrelevant to this measurement, because we're measuring the amount of pixels themselves. The first step is to import the video into Photoshop as a sequence. Each layer is a single frame of the video. Method: we're going to attempt to choose a consistent spot to measure each card from, and mark it with a guide for each frame. We're then going to measure the amount of pixels each card travels between each frame, then compare them against each other. For additional data, we're going to repeat the process on a different part of the cart, both the front and the side. Results will be presented for each, then averaged for a final measurement. Even with margin of error within a few percentage points, we should be able to determine whether the velocity of the double mass cart is closer to 66.67%, 2/3, KE formula, or 50%, DraftScience prediction, of the half-mass cart. We're going to start making the guides for each frame, on a consistent measurement point. As you'll see, there is a consistent skip of the video every 4 frames. This can be seen if you play the video at full speed as well. Because it is entirely consistent and only one frame every 4 is affected, it will not affect our measurements, and only the smooth parts of the video will be used. Now we'll create guides for the double mass object. Next step is to measure the pixels between each frame with a selection. We're looking for the width. Time to enter the data. And keep measuring. Each measurement is the distance of pixels traveled per frame. We just need to average them to calculate the average velocity, pixels per frame. Now we're going to measure the double mass object. I'm going to speed this up, but you should be able to go frame by frame if you want to see the individual measurements. With the front side measurement done, we're going to repeat the process on the side of the carts. Once again, I'm going to speed this up, and you can go frame by frame for more detail. The individual measurements and averages are complete. Finally, it's time to determine how fast the double mass object is traveling in comparison to the half mass one. With the front measurement, the double mass object is traveling approximately 65.4% the velocity in comparison to the half mass object. With the side measurement, the double mass object is traveling approximately 64.66% the velocity in comparison to the half mass object. Overall, when averaged, the double mass object is traveling approximately 65.03% the velocity in comparison to the half mass object. Conclusion: The kinetic energy formula predicted that the double mass cart would travel around 66.67%, 2/3, the velocity of the half mass cart. And the final average was only 1.64% off. In comparison to DraftScience prediction, it's 15.03% off. If DS's conclusions were true, we would have expected to see the heavier cart consistently traveling between 7 to 8 pixels per frame. Yet the average was closer to 10. I would recommend anyone skeptical of this video to follow the steps I've shown here and conduct the measurements yourself. Just make sure to carefully select your measurement point and keep it consistent. This video was quite a bit of work, but now that I've explained the process, any potential future videos should be easier to create. The next step is probably to find another experiment with identified weights and run the same process on it. Thanks for watching.